All right, so we're back this morning working on the little loop box for the flanger and phaser. Obviously where we last left off, we had finished machining our little Hammond enclosure here for all the various parts, the jacks, the DC inputs. I did add a little indicator light. I thought that'd be cool. The two stomp switches and the buffer board. So I thought what we would do right now is just kind of go over the basic, principle of how it operates, and draw up a little diagram here on this sheet of paper as to what we're trying to do, what we're trying to accomplish. So I'm going to do it a little oversized with one of these larger boxes here, so that it's a little easier to pick up on the camera. Okay. All right, so this represents our box looking on the inside of it. But let's start off with, well, let's put in our switches, right? Because we can, for the purposes of this diagram, we can eliminate some of the parts, such as just like the DC wiring. We can add that into another diagram later. But basically what we got are these switches right here. Right, and these represent the terminals on the switch. Okay, so when you see the switch right here, these are the terminals. This is the switch, and then we're going to put in our jacks. Right, we're going to have a jack here and a jack here. This is the input for the box. That's where your guitar will be plugged into at the very first point. And this is the output of the box, which will go on to, in our case, the Echoplex pedal, but it could go into the front of your amp or whatever, but it's basically your universal out. And then we have two loops, right? So we have two more jacks for one loop and two more jacks over here for the other loop, okay? And for that we have a send and a return. And on the same thing over here we have the send and the return. Okay, and we'll just we'll put in the tip connection, as the shield is obviously, the ground connection is obviously onto the chassis, so that's all electrically connected, so we don't really have to worry about that. All of our grounds are electrically connected through the aluminum of the box itself. And the last thing that we're going to put in here is our buffer, right? So we have a assembled buffer, and this is that AMZ from Jack Orman buffer with the JFET in it. It has 4 connections on it. It's very simple. You have basically your positive and negative for your power supply, and then an input and an output. And that's it. That's all you got on this thing. So very easy to work with, not a lot of complications. So for the purposes of that, we're just going to draw it in here, okay? And this is going to be the I side, and this is going to be the O side. So input and output, right? All right, so what do we want to do? We basically want to accomplish 2 different tasks. We want to present all of our effects with a buffered signal, which is being provided by, obviously, the buffer board. So we would want, the first thing that the guitar signal sees is to go into the input of our buffer, right? And then the output of our buffer is basically going to go to all of our signals, right? So our first chain and our switch, all right? So we're going to put it over here, all right? And now on the switch, they're marked, obviously, which side is normally closed and which side is normally open. So what we'll do is we'll put, for purposes of that, NC and NO, right? And over here as well, NC and NO. Now what that means, normally closed, is there's continuity between those 2 terminals. Here and here and here and here. And the continuity between here and here and here and here is not present until the button is pressed. In our case, we're using a momentary. So when it is depressed, you get the other side that would be normally open to be closed, and the side that would be normally closed to be open, right? So you can get in and out from your switch very quickly. You don't have it latch and then you have to trigger it again to unlatch, right? So that's what we want for this box, is to be able to kind of bring things in and out of the chain where we're not going to be using them for prolonged periods of time, which would be, you know, specific to that first album sound. So in any case, let's see what we need to do since we have these double pull, double throws. So the signal would come into what would basically be the common terminal on our switch, right? So then in a normally closed situation, we're going to go, and this will be the sort of the send side. You can look at it as the switch being combined into the send side and the return side. Okay? So in this case, normally closed, we want no affected signal to be present, or, you know, we can blend something in, but we'll talk about that later. So no affected signal. So we're just going to go from this terminal, which would be just our straight connection from our buffer, and go over to our output, right? To our return side of the switch, correct? And then the common terminal here from the return side of the switch will then go on to feed the secondary loop, right? Which would be, you know, for the phaser. So in that case, we're going to move this guy over to the common terminal on the send side of the secondary switch. Okay? Now, if you do press this button in, and you do want to select this loop to be brought into the signal chain, we would have the send side, right, connected to this terminal here, right? And so you would have these two connected. So the buffer would be going, in a sense, to the common terminal switch out of this terminal here, and to the send, which would go into the input of your pedal. In this case, it would be the flanger, so it would go to the input side of the flanger. The output of the flanger would be connected, obviously, to the return. So the return goes on to, you guessed it, the return side of the switch, right? So we're going to go in and connect it here, okay? So if we follow the signal chain further in when you have the switch activated, the return then comes to here. This terminal connects with the common and then heads to the secondary loop. All right, so that we have our affected signal now being present in the chain. So now for the second one, we're basically doing the same thing exactly as the first, right? So we're going to connect our terminals here for our normally closed, non-affected. We're going to connect our send for the phase 90 side right there to our send side to our normally open terminal. And we're going to have our return coming to our right here normally open, and then our common going to the output of the box itself. So you can see the signal would connect with the common, and if the button is not activated, you would not be getting any effect. So the signal then would be transferred to this terminal, go across this jump wire to this terminal, be connected through the switch in the normally closed position to this terminal, and then go to out. So as you can see, when you have neither one of these buttons activated, your signal flow goes from the input through the buffer to this point, 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 and out. So you have no affected signals, no signal losses there, and a buffered signal going on to your next effect in the line, or your guitar amplifier. If you do press one in or the other one in, you can get your affected signal until you release the switch. Now the other thing I wanted to talk about was, to my ear, it sounds like maybe that album was double tracked, possibly with a phased signal, as in one time a take was done with the MXR Phase 90 on the entire time and the two were combined, or perhaps there was a mix of the MXR in there, but to me it sounds like there's always a slight phasing going on in the background, and you can hear the resonant peak of a Phase 90 throughout a lot of those guitar tones, and they become obviously much more pronounced when they're turned on, but I always hear it in the back. So what I thought would be a good thing to do would be to basically include two resistors that we'll select by ear, basically here, right, and here. All right, and what would that would do would provide a amount of affected signal of the phase 90 to be present inside of the with the signal sort of in parallel all the time, and that the percentage of affected signal would be dependent upon these two resistors. Okay, so we might use a potentiometer in there to kind of dial it in by ear, because I think that's really the way it's best to do it. You could do it by math, obviously, but math has its place. But when you're talking about listening to something and, just a smidge more, a smidge less, why sit there doing calculations when you can just twist a pot and then read the pot and replace the pot with a value of the resistance of the potentiometer with a resistor. So that's what we're going to do. Okay, now the next little part of this setup would be, I get another piece of paper. Would just be really simple, but I figured it should be drawn out. So we'll use our box again, right? And this is just the power supply, just so that we can show how we're going to do the power supply in the box. Now the power supply is composed of these items here, right? So we have two jacks and a little lamp here, a little LED. And the reason why I've got two jacks is obviously my power supply that I'm going to be using for this board only has one 18-volt out. This buffer runs off of 18 as well as this MXR flanger. So I figured I would just make a DC breakout box inside of our loop box so I could run from our power supply into the loop box to power the buffer, but also have an output of 18 volts to power the flanger. And since they're right next to each other, it makes everything really nice and convenient. So this is the orientation we have basically. I mean, this is really simple stuff, but we'll just put it in there so that everybody can sort of have it, right? So these are our three parts. We got our LED, and we got a jack and another jack, right? So these two jacks here and our LED here, right? And on the jack you have a couple of terminals, one which would be the pin and one which would be the sleeve, right? And on most effects we have what's called a center negative, which means that the pin itself is the negative connection and the exterior body of the plug is positive, right? So this portion of the plug is positive and the interior is negative. So that's how we're going to sort of do everything up. So we're going to have our LED has a positive and a negative. We also have here a negative and a positive, a negative and a positive, right? So we're going to be running basically everything here in parallel, right? Not in series, in parallel. So we're going to connect our LED to there, right? And we can also put, since they're all in parallel, we can put this here for convenience. And we can run this positive to this positive and this negative to this negative, right? So this is basically our or you could even run it here, right? But this is basically our power supply setup. And then over here we have the last thing that's powered, which is the buffer. And that has also a positive and negative. So one positive to there and one negative over there. So very simple. It's just all in parallel. Just gang up the positives to the positives, the negatives to the negatives, and you're basically done. All right, so I'm going to go ahead and start putting in the parts. And I'm going to start with doing the DC first, putting in the DC ports and wiring those all up. We're going to fit our buffer basically with, I've got this 3M automotive tape, which is double stick, sort of like a foam tape almost. You can get it like AutoZone, and it's used a lot for, like, I don't know, shoddy body work, attaching various crazy spoilers and stuff to your Supra or your 200, 300Z or whatever you got out there in the garage, which I'm a fan of myself. But it's very sticky stuff. It's thick rubber, so it's ground isolating. So I'm going to coat the back of this board with the 3M stuff, and I'm actually going to stick it to the side of the wall right here. And believe me when I say this, when you put it on with this stuff, just make sure you got it in the right place, because you're going to have a hell of a time getting it back off again. All right, so I think that's good for now, and I'll see you guys in a minute when we have the thing sort of wired up in about an hour or so. All right.